I'm Catherine Lawrence. I work with the Science Gateways Community Institute, and today's webinar is featuring the Starfish storage service and software, which we'll hear about in just a few moments. But you are currently muted and your video is off, and please do leave them off so that our recording comes out great. But in the meantime, if you do have questions along the way, you can submit those through chat. We also will be recording this and the slides will be posted. So if you have anything you want to see back again, you can certainly find that there. And that usually gets posted pretty soon after the recording is made. So I'm just going to tell you a little bit about the Science Gateways Community Institute. We're funded by the National Science Foundation to provide support for people building and operating science gateways and the broader community of people who are involved with them. And we do that in three main ways. We provide support for building and running gateways, which is primarily through consultants, as well as a catalog of gateways and software for building gateways. We also provide a number of education and training programs, including this webinar. We also offer Gateway Focus Week, and if you didn't notice on the first slide, our next Focus Week, which will be offered virtually, will be coming up this summer, and registration is currently open for that. It's a great intensive program where you can learn about how to position and market and grow your gateway and make it sustainable. We also have student-focused programs, including a coding institute this summer, primarily directed at undergraduates, and a lot of resources on our website. And then finally, we're about the community that's in the name of our organization. We have an annual conference. We also have a Google list that we use to allow people to communicate with each other with questions that may be a concern to multiple people working in the Gateway area. We have two ambassadors programs, a collaborators program, which includes partners and affiliates. And then if you have news or jobs that you'd like to promote, do let us know, as well as we welcome guest blog posts. As part of what we offer, we do ask, if at all possible, for you to share with us your feedback at the end of this webinar. We use it as a way of figuring out what other topics are interesting and useful to you. We also use it as a way of improving what we offer. So this link will be posted in chat towards about halfway through this presentation. So with that, I'm going to hand it over. We have today Peter Galvin and Milo Gola, both from Starfish Storage, and hopefully momentarily we will have Jacob Farmer, who is the CTO of Cambridge Computer, which is kind of a related organization to that, the Starfish Storage. What I'll ask you to do is, as I mentioned, post any questions in chat, and both Peter and Jacob will field those questions. I'll keep an eye out for them, and we'll ask them at an appropriate time. So with that, I'm going to, I don't know, Peter, if you're prepared to share your screen with any slides, or whether you want to just jump into some kind of demo. I know you were saying that would be what you would do. I
can, while we wait and see if Jacob joins, I can certainly start with the slides and then do the demo, do the whole thing without him if we need to, but
okay.
Don't want to hold anybody up waiting for him.
All right.
Yeah, see the slide deck okay?
Yes, we do.
Excellent.
Thanks.
So thanks for having us. This is Starfish. We take the met out of metadata, or we harness the chi in archiving. We have a few kitschy terms. We don't have any marketing, but the marketing we do, it's all about kitschy stuff, like starfish shaped fidget spinners. So we're a very sophisticated platform for unstructured data management. a couple of ways to think about us. If your files could talk, what would they tell you about themselves? And if your files could listen and obey, what would you tell them to do? So we have a very high scale, high throughput, very functional discovery engine. And we couple that with execution. It's one thing to know that you have, petabytes of files that haven't been opened in 3 years, or of raw files that you only need before they get processed and they're sitting around, or files owned by people who have left. Those are the types of things you can discover, but it's another thing to be able to do things like take all your TIFF images that haven't been accessed in 3 years and push them to an archive. That's the kind of thing you can do. And when talking to the Science Gateway folks, we thought Starfish might be of interest because if you have a gateway, you probably need ways to feed that gateway, and possibly Starfish could be used in that use case as well as many other use cases. So on the data catalog side, we have massive scalability, billions of files, petabytes of data. We're at some very household name sites, some of which we can mention, places like Lawrence Livermore National Labs, where we read all their metadata from their Lustre cluster, put it into a sideband Postgres database that's embedded, so you don't need to know that or manage it yourself. And now instead of asking your file system questions or your object stores or your 2,000 file systems, as we have at one hedge fund, you ask the database. And not only can you ask it about just the metadata off the file system, but you can add your own metadata. You can do that by tags. And by extracted metadata, we can open files, extract headers, and put that in the database as well. And I'll show you all that during the demo. It's simple and turnkey, but very customizable as well. On the execution side, we have a scale-out data mover or batch processor. It runs on Linux and Windows, so you can use this to manage, say, CIFS mounts as well as NFS mounts or local mounts. We support pretty much every file system and almost all object stores. And then we give you commands built in, things like migrate or archive or delete or hash or extract metadata, but we're designed to be fully extensible because we're in a lot of verticals. We're really catered to anybody who has too many files, and that tends to be anywhere from media and entertainment through oil and gas, through a lot of biotech, HPC pharma, and universities, edu. Because of all that, we certainly can't come up with the command that each of those types of verticals needs to do their thing. So we've designed the execution engine to be very extensible. You can run your code harnessed by our jobs engine to make it restartable, loggable, scalable, scales out across multiple systems, all of that. I usually stop and ask there if there are any questions, but we have a lot of people and everybody's on mute. So I'll keep going, but feel free to put your questions in chat.
And they're welcome to join at any time. And I'll also mention that Jacob just joined. So his audio is still connecting, but if you want to transfer everything over to him, you're welcome to. It's up to you.
Hey, Jacob, you on yet? I'll keep going with this slide. And is that Jacob? And he can interrupt when he's ready.
Yeah.
So here's the life cycle of Starfish and its metadata. We read the metadata off of whatever target you point us at, load that into the database. We're really designed for querying against the database and then taking the result and doing whatever you want with it, usually sending it to a job queue to execute a job against the results, where the agents that you've set up can be one, that's the default, but you can be many. We can scale that across dozens of agents if you need more throughput, more CPU to process and all that. And then the agent's results get loaded into the database. So we keep track of everything we've done to files via Starfish, as well as metadata you've added, as well as metadata that came off the file systems. A quick view on the topology of how Starfish runs. It looks complicated, but it's actually simple. All of this really just sits on one server by default. We run on Linux, virtual or physical. Once you get to about 1 billion files, physical is preferred. Starfish comes with the embedded database, the scanners to read metadata, an event processor if you have things like Linux. Lustre, we listen to the events coming off Lustre and feed that into the ingest service. And then agents to run the job queue, and these can scale out as mentioned. The database talks SQL. You're allowed to talk SQL directly if you'd like to. Again, very open. we provide you with a dashboard that I'll show you called Redash. You can write your own SQL queries, and we provide an API, REST API, to get to the core functionality. And we provide two interfaces to that, the CLI and the GUI. I'm Peter Galvin, by the way, the GUI product manager. But we have a CLI, so that gives you scriptability, and you can also write your own code to the API as well if you'd like. Jacob, you ready yet?
Yeah, if you're hearing me, I'm happy to chime in.
I hear you. Take it.
All right. I think if I just go mute in the middle, Peter, fill in for me.
Will do.
So we've been in this world of research data management for a long time, and we hear a lot of stories about what I would call institutional gridlock, where somebody's waiting on someone else to tell them what their objectives are, or somebody else puts the kibosh on someone else's job. So we're looking at managing the life cycle of data, and we feel like there's at least these three kinds of stakeholders. There's the people who do storage management, who are concerned with the devices. And then there are the people who actually create and consume the storage, and they don't really care about the devices, they care about the files themselves. And then there's sort of these other people who kind of oversee it all, who don't care about the files or the devices, they just care to know that everything's done right. So we feel like in order to do anything, you kind of have to get at least two of the three, if not three out of the three of these stakeholders involved, or at least be able to satisfy their needs. So I use an example of a simple example. We had a client who just wanted to clear data off of a big storage system and move old stuff to to cheap, deep cloud storage. And the very first problem they have is that their users object. So it'd be great if you could get a little bit of interfacing with the users to find out what they're willing to move, not move, and then to sell them on the reason why you're going to move their data, show them they can get it back, that kind of thing. And then as they were about to hit the big red button and move the data, they learned that there's a policy that nothing leaves the building if it hasn't been scanned for personally identifiable information. They want to make sure the data is properly anonymized. And how are you going to do that on multiple billions of files of research data? So I wouldn't trivialize it, but we built a PII scanner, personally identifiable information scanner for Starfish, to meet the use case of this particular customer. And it wasn't terribly hard to do. As we like to say in Starfish, doing something to one file is usually pretty easy. It's when you need to do it to all of your files that it's kind of hard. And that's what we enable. So we make it easy to take the logic of extracting text from a file, searching for something, making a determination and updating the database. All that's easy to do, even if you have billions of files. So that's kind of the grand vision. And then, the product's evolving pretty quickly. Our goal is to get closer and closer to users so that we can service more specific needs and we're doing a lot more specific stuff in science, like we've been doing instrumentation workflows where data comes off, some piece of apparatus and a workflow starts that Starfish manages, that kind of stuff. What else to tell? I think we have one more slide in this deck that's relevant. Which is that science is kind of our target market. So, the kinds of things we hear about scientists being concerned about is, that it's open, that there's no lock-in, nothing proprietary. Whenever we move data, it's not like we're messing with it to make it unreadable. There are a lot of products in the market that move data automatically to cloud stores, for instance, and even if they don't make the data proprietary, they might take control over how you name the objects in the object store. We make all of that very accessible to you. Even our metadata is stored in an open format. It's in Postgres, and we make the schema available to you. So, the goal is really to be something that's neutral and independent of your storage infrastructure, that's flexible and open, and that will, you probably still, we know science is a long-term perspective, not 1, 2, 3, 4, 5 years, but 10, 20, 30, 40, 50 years, maybe longer. We're good for that. So that's the overview. Any questions or comments before we jump in and show you what it looks like?
The question came in from Donnie. He asked, is the schema available to anyone or just to paying customers?
Well, we only have paying customers. It's not an open source product. So we call it open, but not open source. And if you are a paying customer, we make our schema available to you.
And Mona asked, what is your fee tier?
our fee tier. So we license, but there's three main components to Starfish. There's the base system, which is the catalog metadata. We'll show you all this in a second, tagging, etc. And then there's our batch processing, which is the ability to actually do stuff with the data. And then we sell what we're going to show you, a thing called a storage zone. We sell storage zones as an add-on feature. And then the other metric that gets involved is capacity. So in sites bigger than a petabyte, we charge a premium for each petabyte of storage under management after the first one. And then we have pricing for higher education that's dramatically cheaper than our corporate pricing. Like a small site EDU might spend $10,000 a year with us, and hopefully they have lots of ROI that they can get from that.
Okay, I think that's it for questions so far. I guess I would add to Mona's question in terms of, so gateways are often funded by soft funding. They may be supported by their institution, but how, or I don't know if you are currently working with gateways, but how would a gateway kind of plan ahead and budget for something they want to have be sustainable, but they're going to be using your software for the long term?
Well, I have an imagination around this, but I think it may come from you guys. So we're always looking for synergies and how to be good corporate partners or citizens. So a lot of times the people who have the project or the need don't necessarily have the money, but the money might be a half step away. So like a good example for that is that, and let me make this broad statement, and then I think we should show you what the thing does, and then come back to how we could be partners. So there's this problem, I think, in research data management, which is that the granting agencies all want people to collaborate, and they want them to share, and they want open access to data. They want all of these things, but they pretty much never provide any additional funding for those things. Would anyone like to challenge me on that statement, or is that pretty accurate?
I would guess that's pretty accurate. So
then the question becomes, like, where do we find the ROI when there's no money lying around? And a big premise, if we went back to my triangle diagram that I put up before, a big premise of that is that the people with the money always are the people in storage management. Like, you got to buy storage, and you can't get away from that. And if you're putting data in clouds, you can't get away from your cloud bill. So what we find is that we can usually get a really compelling ROI for the storage people that then pays for the product. And then the product is available for everybody else to use for data management. I'll give you a cool example of that. We did an installation for Duke University Health System. And they have a big environment, and it's too big to qualify for our normal EDU small site, which means it's like, it's big, it's multiple petabytes. And it's and because it's in the health system, it didn't qualify for our EDU discount. So they paid what I would call real money. But we were able to help them free up over $2 million worth of storage on their expensive storage devices and get it into their cheaper storage devices. And then when we were done with that, we were able to help them move data to even cheaper storage devices. So the software has paid for itself multiple times over through the boring act of just moving data somewhere cheaper. But then there's all this extra good stuff available for data curation and collaboration and for everything else. So I would say to you folks, like, the best thing I think you could do is try to understand the capabilities that we have. And then if you see a place where we should be working together, we'll approach it with an open mind. If we can do something that makes, nominal business sense for us, or if it enables a project and it tells a good story, we're open like that.
Great. Another couple questions came in. Mona also asked, does the database sit local to the customer, or are they stored at a place hosted by you?
So it's all your data that you own. You could put it in a cloud, you can have it on premises, but we're just providing the orchestration and metadata software. So we're not a storage device or a storage management service.
Excellent. Okay. Great.
All right.
Well,
So
carry
let's show
on.
you. Let's show you what this thing looks like. It's such a simple concept that I think, I think we've implemented it really well. So I think you'll dig it. All right. So what you're looking at here looks like a file browser, but really it's our database. So we're walking the file system. We're synchronizing the metadata into a database. We're doing that all the time, and as we're doing it, we're also tracking the version history. So what we're going to first just show you is kind of what's in the database. So on that upper left, if we click on volumes, those are a list of disk volumes, and we support all the major storage devices you're ever likely to see. The ones that are unique to high performance computing, the cloud resources, the object stores, the conventional enterprise NASs like NetApps or Isolons, and we support, ye old Windows Server or Linux Server. So as long as it's a file storage device, we support it. Now we usually get asked questions about like things like Dropbox or Box.net or SharePoint. We don't support those devices today, but sometimes there's integrations we can do with them. All right, so if I pick a storage device, then what you're seeing in the middle of the screen are the files. And they're organized just like any other file system, right? There's folders, and then you click on one, and inside are files. But we're gathering up some other metrics while we go. We're like totaling up how many files and how much capacity are in each branch of the tree. We also have metadata tags on the directory level. So if you look at one of these directories, there's a bunch of tags on here, and the tags are just an arbitrary string. Peter's just going to type one in. Oh, I think he's clearing one and then typing it in. So we've been using COVID-19 as our demo tag. He's just going to type in COVID-19. And let me show you a cute little feature while we're doing this. Peter, why don't you open the command line logger? And for those of you who like to automate things or do things in the command line, whenever we're doing stuff in the GUI, we log it in the command line format. So if you wanted to run it from a script or use the APIs, you can actually use this as the teaching tool. So there's the command that the GUI issued to put the tag on the directory. All right. So why don't we show you what happens when we put a tag on a directory? It actually inherits all the way down the tree. And this is just an easy way to classify a whole bunch of data in one shot. So Peter, why don't you pop over and just show where that tag is located? Right, so there it is. We call it an explicit tag because we put the tag right on top of the directory. So it's basically a way of saying, this directory, I pasted it here. But anything downstream from that directory inherits the tag, and in which case the same tag shows up as inherited. And we can query for it either way. So you could say, get me all the directories tagged explicitly with COVID-19, or get me everything underneath the directory with the COVID-19 tag on it. And this applies to files as well. So if we picked a file down below, the file can have both explicit and inherited tags. So again, very easy way just to put some information into metadata into the database. Now, because this is a file, files also have key value metadata. And the way the key value metadata works is that we run a job, we query database, do some stuff, update database. And the way we update database is to format JSON from the job code and just put it in the database. And then what happens is that each of the values gets individually, gets indexed and becomes an individual property of the file. So we support all different kinds of So we can do anything we like with the job code. So this first job was that one I described where we looked for personally identifiable information. That's where we opened the file, we did a query against the text results, and we updated our database. The next job is a hash where we actually took both an MD5 and a SHA-1 hash of the file, put it back in the database. And hashes are useful for all kinds of things. You can use them as unique file IDs. Like if you query Starfish with a hash, it'll tell you where the files are that match that hash. And if you can use the hash to do data integrity checking, or you could use the hash to find duplicate files. So they're pretty useful to keep hashes. That next job is metadata extraction. That's just where we open the header of the file and we pluck out all the metadata tags. This file, I think, is a DICOM file. So we support all different kinds of scientific data formats, as well as typical Office data formats. And then Peter, why don't we show the flip to raw data? So that's how we show you what the data is called under the hood. So if you wanted to do your own coding, you know, you don't have to go read the documentation. All right, then on the last two jobs in here, I should mention, these are data movement jobs. One is where we copy the file from here to there between file systems, and the other is where we copy the file to an object store. And again, whenever we do anything, we just record what we did. And in the case of copy jobs, we can use this information either to restore the file back to the original location, you know, or to tell the user where the file went, right? So you could query our database and say, hey, where's my file? And we would tell you. And if, or we could bring it back for you automatically. One more thing to show you in the database. Hopefully everybody gets that so far. One last thing to show you is how we keep how we keep time in the database. So Peter, can you do a quick query going back in time and then maybe even comparing some dates?
Sure. Here, I'm just picking a year ago, and then I'll compare it to today, for example.
Someone just asked whether the file content's coming from the database or from the file storage. It's coming from the database. So first we scan the storage device, put the data in the database, and then all of our interactions after that are with the database. So Peter just queried 2 points in time and compared them. And we're sort of demonstrating two concepts at once. One is that we're able to go back in time and see what the file system used to look like, which is great for finding files that moved or restoring files that were deleted or archived, or just getting statistics on data growth. So we went back in time and then we compared it to today. And what he's also showing is how easy it is for Starfish to compare two directory trees. And we use this for a variety of things as well. So hopefully what everybody just picked up so far is that we have a really simple and flexible system of making a database out of your file content. And I think if you just sort of mentally pause there and just think about, do you have any applications where it would be useful to know, from a database standpoint, what's in the file storage? Like, that's the first step. And I said, when we license the product, we license it, many of our customers just buy this databasing capability. And we can show you toward the end if it's interesting to you, but we have like hundreds of reports across the whole storage environment. Like if you wanted to know how much capacity was being consumed by this project or this user, or what the growth rate of storage over time looks like, we got all that stuff. But anyway, just stop and think about what it means to have a database like this. Now, Peter, can I ask you to narrate how we build queries and how we do stuff? Because suddenly there's a lot of noise in my background, and I'm worried that it's going to make it hard for everyone to hear me.
No problem. So far, you're coming through loud and clear. All
right. Well, yeah, I think the noise is it's a vacuum coming up my stairwell. So it's going to get
exciting. I'll also mention that there's a question that came in from Mona asking, she said, are you saying that the raw file content is stored in the database when you display the raw content?
No, the metadata of the file. All we're reading is the file name, the file directory name, the permissions. Yeah, Peter, why don't you just sort of give a quick show? So what we're showing you is everything that comes back when you issue a stat command against a file. So Peter, put it back into formatted. So oh, sorry, was this the question? What we have in the system is file system metadata, and then our tagging, and then any metadata that we derived from our jobs engine. And all of that's in the database. And the files themselves are sitting on the disk. We know where they are, but we're not doing anything to the file itself other than taking metadata out.
Yeah, when we talk about raw data, it was the raw view of our database. This is the cooked view, and it's all metadata about the file, not the file's contents.
Did that answer the question?
Waiting to see whether Mona says so. Yes, she said.
All right.
Thank
you. Mona's happy. Yeah, so it's really a very simple concept. We're really just listing the files, putting them in the database, and then adding extra descriptive information to the database so that we have like a meaningful index of the file content of the files. Now, the next major piece of Starfish is to do stuff with using the by querying the database. So what we're going to show you is how we build a query and then how we take action based on the query result. And I'm going to let Peter just navigate that whole thing so that you guys can hear.
Yeah, so over here is our search pane. You can just type in arbitrary searches like find memory file or directory with medic in its name. Notice that's a wildcard search. Notice that's a wildcard search, so it's not using our indexes. It's just a virtual machine I do demos from. And then we have all sorts of conditions, basically other fields in the database that you can do queries against. So you can do a name search or conditions or both. We'll do both for you. But here we have everything POSIX, find me files that haven't been accessed in a certain amount of time, or find me files owned by a user ID that has no username match, so orphan files, or even find me, directories that are world writable. We have metric things like find me every directory with more than 1 million files in it. You can imagine we've seen, because we run a lot of big sites, we've seen a lot of nightmares, like a directory with 40 million files in it on a file system that supports 1 million files per directory. They wouldn't have noticed it, except Starfish figures these things out. Full regular expression searching, so as complicated a name expression as you want. Storage state, find me things that have been copied before or haven't been copied before. So you could tag things important, and that means copy them to 3 places and then do a search, find me everything tagged important that hasn't been copied to 3 places and make those copies, for example. But I'll just add the tag back in here. Our favorite, COVID-19. For April Fools, we did COVID-21 just to freak people out. So notice we had 816 matches, and now we're down to 125 matches. We always try to tell you what you're seeing on the screen. And this is the result set, which is interesting, but you can also then do that query and take an action. So here I'll go into action mode. I'm going to take an action on everything that matched. Here are the built-in commands we have: delete hash, export to CSV, archive. You can also plumb in your own commands per site. So here's the archive command. It's a data copier and data mover. So I've already defined targets to Starfish. If it's say a cloud bucket, then you put in your credentials about how to access it. We can push data and bring data back all the way from Glacier and Deep Archive, for example, or from Swift or from Azure. And then we have options. If you don't click delete after, we're just copying. If you click delete after success, then we're moving. And we can add all sorts of features like compress and tar on the way up and back to save on storage cost and egress fees, for example. And we can pass along storage target information to tell the object store what to do with the object. At any point, if I hit confirm, that fires off the job and our jobs engine that gets fanned out across the agents. But we are very belt and suspenders-y, so here's the dry run. Tell me more, Starfish. So here again is the thing we're about to take action on, all your options, and this is actually the REST API call we're about to make. So you can check parameters there, or now the GUI is teaching you not only how to use the CLI, but how to use REST as well. And then if I hit confirm, that would fire off a job in the jobs engine. This is all the browser tab. Here's the jobs tab. Here, past jobs, and we give you all the details you could ever want about the job and how long it took and the throughput. I'll just find an interesting job here for you. So here's an archive job that sent the data to another file system, and here are all the details about how long it ran and if there are any problems, and even the throughput, so you can decide if you need more agents to help push data or not. We push data at line rate generally, so whatever resources you give us, we can take advantage of.
So an important point, though, is that a job is anything you want it to be. Like the most common things people ask us to do are copy, move, and delete. But you can do anything that can be done to a file can be done in our jobs engine. And the difference between just running any old script and running your script in our product is simply that it runs reliably, it picks up where it left off, it logs itself, and it has the option of updating the database.
A couple questions came in too. I don't know if this is a good point in time to
Sure.
interrupt you for that. So one, I think, is a clarification or confirmation question from someone who said, did you say the raw files are outside of the system? Are raw files local to Starfish or separately stored within a customer's premise?
Got it. So yeah, so let me again clarify fundamentally what we're doing and not doing. So when we use the word raw, we didn't, all we meant with raw was that we were trying to show you what the data looks like unformatted under the hood. So Peter, why don't you pick that up again?
Sure.
Okay. Now, when scientists use the word raw data, they oftentimes mean the data that comes off their instrument before they've processed it. So Starfish is often used to manage instrumentation workflows where we grab data as it comes off the machine and we move it, process it, wriggle it, jiggle it, deliver it somewhere, gather metadata about it. But we're not otherwise holding the data. We're just holding metadata about the data. So Starfish is.
I just made a note to rename this raw metadata to avoid.
There you go. That's the right term for it. So,
yeah.
So really all we're doing, the first part of our product is observation. We're looking at what you call your files, where they're stored, when they change. And then if you want, our jobs engine can interact with the files and do stuff to them. Now, a common kind of raw data workflow that people use Starfish for is, and this speaks to the problem of open access to data over time. Like, let's say I have a gene sequencer and it makes a file. Starfish could pick up that file on day one and make a copy of it in like the super cheap deep tier of Amazon, which is like, about half the price of the cheapest way you might otherwise store data. So you put a copy there, and that's a great place for a backup copy or a long-term archive. But if we put a copy there on day one, it's our backup in case something else goes wrong. Then we maybe move the file over to a high-performance computing system where it gets processed and they do whatever they do to it. And then at that point, we could just delete it because we've got a safe copy of it somewhere, or the user could delete it whenever they feel like it. So it's a simple workflow that just makes sure that you've got good data, make sure that you can curate it properly, maybe puts it in a space where collaborators could get to it. It's kind of whatever it is that would make, your file experience work for you. Starfish can orchestrate that. Hopefully that answered the question. Let me show you one other really important concept, and then I think we can just do total, free fall Q&A. So we're trying to get users. What we've shown you so far is really like a systems administrator tool. And what we've been trying to do is get users closer to the data and closer to storage management. And we have our first release of that is something that we call storage zones. And what a storage zone is, Peter's going to open one up here, and we'll pick an example of one. And I'll do my best to just explain it with words. So it's likely that any given customer has multiple storage devices. And within the storage device, they have a big directory tree of all the files that everybody uses. So in a storage zone, we can pick directory branches from all over the storage environment, either from the same storage device or across storage devices. And we can group them together into a thing we call a zone. So when we build this zone, what you see here is something like a virtual volume. And this virtual volume called gene sequencing, the first directory branch is on a GPFS storage system. And the next one is on an Isilon storage system. The next one's on a Lustre storage system, and then a NetApp storage system. We went a little overboard to show you that you could have multiple storage devices if you need to. I think the last two are on S3 buckets. So the idea is we group all this like data together. And once we've grouped it together, we can then assign users to have access to these collections. Now, what it means to have access is not to be able to access the files themselves or to be able to do anything with them. All the users can do is see that those files exist, see their names, see their directory names, see the metadata, and the users can apply tags. Now, you might think, gee, applying tags, that doesn't let me do very much. What if I wanted to move the data? Well, if they wanted to move the data, we'd make a tag called move the data. And if they applied that tag, then we would run a job that says, hey, get me all the files tagged with move the data and move them over here. So what happens is that the tagging system becomes like a language, a very simple language for expressing what you want to have happen to the storage, to the actual files themselves. So it could be copy to archive. It could be delete after 90 days. It could be anything that you use a tag to describe. And those tags, because they can be applied through API, those tags can be done programmatically from another application. So hopefully what you see here is that this becomes a really easy way to describe what you want to have happen to the files, just using simple tagging and metadata concepts. I see a bunch of questions are coming in. Peter, are you trying to fulfill these, or should we talk them through?
Yeah, I was answering in line while you were talking.
Okay. Should we try to? Is it worth taking a second and answering them in English?
What are you implying about my typing skills?
Oh,
Sure.
I just don't know. If I wasn't sure if everybody's following the type narrative and the spoken narrative at the same time.
Yeah, exactly.
It is, I have to say, a lot in there. We'll certainly grab it and put it also in with the archive of the video and slides, so that folks can, if that question was something that came up. But I do want to make sure that the question that was asked by Billy about whether Starfish can index files in OneDrive, whether that answer about Lustre and GPFS is the answer.
No. So
Oh, okay.
It's not the answer. So
okay.
on big. So mostly where we play is on file servers and high performance file systems and object stores. So, and we're really good in those environments. Those are really hard environments to work in. So like for instance, we're working with a couple of the big national labs where they have these massive file systems and they're churning like crazy, and we're cataloging their contents, and they're really excited because they normally can't possibly measure what's inside their file systems or do anything about it. When we get down to systems like OneDrive, we haven't played a lot there yet. And the challenge for us is that there are so many of these different systems, between Box and Dropbox and Google Drive and OneDrive and SharePoint, and I'm sure I'm forgetting some. We haven't built interfaces to those systems. So some of those systems work like a regular file system, and we could scan those file systems and have access to those files, but we're otherwise not doing anything specific to OneDrive.
Great, thanks. So Peter, I guess it's up to you. You did answer those questions. You mentioned that you might show in the demo how to put something somewhere and then get it back. Do you want to, is that a good thing to show?
Yeah, and also Donnie was asking about essentially if we can notice when files are created and then process them, say coming off an instrument. So that was mostly what I was answering there, that we can either discover them, but sometimes people don't want us to take action immediately when we discover them because the instrument could still be writing the data. So they'll, as part of the instrument pipeline, they'll have a file created at the end saying, yeah, the writing is done, Starfish, you can now process the files, and we can watch for that signal file. And if we see that, then we can start processing the data, for example. This is just a visualizer, by the way, I thought I'd bring up for ICANN for when people were talking.
So let me answer that Donnie's question a little bit more generically, which is that there's usually people imagine things like triggers, and the challenge with triggers is that the clues don't really exist everywhere. So when we read information from a file system, we don't necessarily know if a file is done being written. Like we're an observer, we can't tell. So the way our paradigm works is actually, again, it's super simple. We're scanning files and getting the records into the database. We can always refresh a branch of a directory, and we're really good at scanning. But then once the database is built, we query the database and we do something with the result set. So the trigger, when I use the word trigger, it's sort of like trigger in quotes. We query the database. If there's files there that meet the query criteria, then we'll take action on them. And if there aren't, then we wouldn't. So the example I like to make, if you put a tag on a file called delete me, it won't just delete that second. It'll delete whenever a job runs that queries for all files tagged with delete me, and then it'll get deleted. So the nice thing is it's a very simple way to do things, and it's really easy to navigate around the corner cases because we're not trying to do anything impossible, and we're not relying on heavy duty integration with the storage systems. We're kind of doing this the way that most people would have just, if they were scripting it themselves, we kind of did it that same way, just making the parts that are annoying and hard, we made those easy. And then the really funny thing, I think it's funny, is that almost all the code in our system is error handling code. Like none of the stuff we're doing here is fundamentally a complex concept or hard. It's just hard to do reliably, consistently, and at large scale.
So there was a question that came in that Peter has answered, but it might be something of interest to other folks about, does the file systems have to be already public, and otherwise, how does Starfish gain access? And
yeah,
Peter,
so we have to have access, or obviously we can't scan if we don't have access. Usually we run as root in the environments we run in. And this is another important concept for those of you who kind of lived in this world. The force is like everybody wants proper data management. Like we can all, raise your hand if you'd like your files to be properly managed. And the funny problem is that there's these obstacles that keep them from being managed. And some of them are fundamental. So the first one is that you can't manage somebody else's files unless you have root privileges in the storage system. And that's something that no one gives that out easily anymore. So one of the reasons why Starfish has been successful doing the kinds of things we do is because in some organizations, we're like the only tool in the world that can move data the way they need it moved or interact with it the way they need it. So they give us root access because they have to. And then once we have root access, then we can get the metadata for everybody's files and put it in one place. There's another reality of data management, which is that when files move, they break your data curation systems. Like a lot of people will store a link to a file in a database somewhere, and then somebody goes and moves the file, or even more innocently, they rename a branch of a directory, and everything downstream effectively got moved. So, we have the ability to clean up for those things relatively easily. And then there's a third problem, another one of these fundamentals of life, which is that sharing files is something done within institutional boundaries. Like file servers don't work across institutional boundaries. And that's why people start using things like Dropbox and OneDrive, and maybe they get fancy and they use Globus. We have some tools that we're building that allow you to build storage systems that do span across multiple institutions. The easiest way to use those is to kind of configure it in a cloud or a neutral resource like an Amazon cloud or a Google cloud, and then use our device to kind of localize it for each institution. That's a whole conversation in and of itself. If that's a problem people have, I'd be delighted to chat with them about it. But basically what we're trying to do is we're trying to look at these obstacles to moving and sharing and doing stuff with data, and to try to do it in ways that, that haven't been done before, that hopefully are simple and, accessible.
So Donnie had a follow-up question to what you explained earlier. He said, so the database provides an indirection and you trigger on database query results, not on file system state.
Correct. So before we run a job, we might true up the file system with the database. That's a switch in our commands. So like, let's say that we scanned it an hour ago and somebody added a file and you want to copy everything now. Then you'd run a fresh scan on that directory before the job runs. And that's automagical. Like, you don't have to, that's just a switch in the command structure, not something that you got to go do separately.
So you mean you set it as a preference and then it'll do it automatically anytime you pass?
Yeah, when you run the job, like if I make a copy job, a parameter on the copy job would be run a scan before you run the job.
Okay. Great.
Yeah. So,
Thanks.
I mean, and if you think about it, that's what happens anyway. Like if you're running any other script, it has to read the files in the file system. So we're just batching that up a little bit. But usually, and also you can, if you run any of our jobs twice, there's also a switch that just says the next time you run it, only take action on files you haven't already taken action on.
That's nice.
Yeah. So, I mean, you can imagine the whole idea is to make it easier to script stuff. So the kinds of things that are just annoying that, I ran my thing twice. I didn't want to run it on every file twice. Those are things we built in. And that's the advantage of having the database index as the input for the job versus the file system. Right, like file systems just don't tell you enough information, and you can't really manipulate the metadata in a file system, the way we do in our jobs processor.
Excellent. So since I see we have about 5 more minutes, so and there are no current questions, I'll let you know if any other ones come in. I don't know if there's other things you'd like to mention or cover or sum up.
I think I'm curious to know if anybody if this is like anyone's been inspired, like they think how a technology like this could help with a use case they have.
Well, Mona just came in with a question. She said, so can we script our own action? And if so, which programming languages do you support?
Yeah, you can script it in anything. So Python, Perl, Golang, whatever you like.
We write our own in obfuscated C, of course, but you're welcome.
Yeah, right. We prefer obfuscated C.
or Perl, which is the equivalent.
Yes.
No, whatever, if you can run a script on your computer, you can point Starfish to run it across a billion files.
Great. So yeah, I'll invite folks to either post something in chat if they have some thoughts that came up, or we're a small enough group that if you wanted to just unmute yourself, you can ask as well.
Yeah, I don't mind that.
And in the last couple of minutes, I'll just make sure y'all know about our upcoming month's next webinar. Any takers? Now, earlier we were talking about returning to this model of how the return on investment is for paying for something like this as part of a gateway, which might be on soft funding, for example. Is there more that you could say about that?
I mean, the best thing I could tell you is that we're not trying to get rich off of academic or nonprofit research. So we're kind of interested in anything that makes business sense for us. So business sense means we're learning something, we're doing something impactful that tells a story. We're helping somebody who has a big mouthpiece. They're likely to tell somebody else. Maybe your gateway collaboration is with a university that has a big research arm, and it would help for them to know what they might be interested in what we're doing. And there's always the spreading of goodwill and letting people know what we're doing. So I think I'd say the purpose of this presentation was for you to understand the kind of stuff we do and to think if it could be useful for you. And then if you think so, we're always happy to talk about whether there's a way we can help you despite having money to spend. So,
great.
I mean, I've been working on some projects with university libraries who don't have any money, but they're interested in curating science data. So for them to be thinking about what we do and using it for something constructive, or we certainly discounted things for the right kinds of customers that they came up with something we could work on together that feels like it advances the cause of the product. So I'd say we're just a friendly, flexible company like that.
Great. Yeah, so just so you know, I see Peter saw this comment. So there are definitely folks who are interested in talking more to their team and then following up with you for sure. What I'll do is I'll take a moment to just talk about our upcoming webinar, and then we'll wrap up in case any other questions have popped up in the last minute or so. I just want to encourage everyone, I put a link in chat for sharing your feedback. We like to get your feedback always. And the link is, as I said, in chat, but also here on the screen. And then next month, our presentation is going to be about CloudBank, which is an NSF-funded resource, and how they can support science gateways as well. So that is May 12th, also Wednesday, and we'll hope you'll consider that, as well as applying for Gateway Focus Week if you haven't had an opportunity to try that excellent program. So I don't see any other questions that have come in. So so I would like to thank both Jacob and Peter for sharing this really interesting and different kind of resource option, especially given that metadata is such a tricky thing to wrangle. It's really terrific to see new opportunities for gateways to manage their data in ways that haven't necessarily been tackled before. So,
Catherine, I'd say one last thing to that, which is that everybody's talking about metadata as something you need, and it serves all different purposes. We've kind of found this intermediary metadata space, space between applications and files, where there's this real gap. And I think the key thing about what we're doing is we've made it really easy to capture metadata and then use it for something. So even if there's another metadata, I should have mentioned this, my very first paying customer for Starfish was the Library of Congress, where they have more metadata systems than you could shake a stick at. But shuttling metadata around and capturing it and discovering it in a workflow and just kind of using it to guide a storage policy, those are all new ideas. And I think with the nut we cracked was we just make it dirt simple to do that. You don't have to do a whole lot of work to classify your data and then take advantage of it.
Fantastic.
Anyway, that's my closing statement. How about that?
Yeah. Well, and Library of Congress is no small fish, huh? So to use a pun
it's actually
metaphor.
really funny. We've got a handful of really large libraries that are using or looking at the software, and they actually all see something completely different in it. They have different reasons why they find it interesting. I hope one day to get them all together so they can at least agree that something in particular is useful to all. But it's very Swiss Army knifey.
Yeah, that's awesome. Well, thank you so much for pulling this together and joining our community for the afternoon or morning, depending on where they are, and talking about Starfish. I appreciate it, and we'll coordinate with Peter to get his slides, and
perfect.
And we'll post this video for everyone to, and as well as information on how to reach you on our website.
All right, terrific. Thank you all.
Awesome. Thanks, Jacob.
Bye.
And thank you, Peter, too.
Thank you.